Hello everyone, my name is AgusPratondo. I am a faculty member at the Department of Multimedia Engineering, School of Applied Sciences, Telkom University. Telkom University is a private university located in Bandung, West Java, Indonesia. In this video, I would like to share the progress of my recent study on fruit classification, particularly apple classification. I will explain the background of why this research was conducted and the purpose of this research. I will also describe the methods used to build the models that can classify apple images. Then, an explanation on how the experiment was carried out and the result will be presented. Finally, the conclusion of this research will be presented at the end of my presentation. Some reasons that underlie our research on this apple classification are as follows. First, on the distribution and marketing of apples, the type of apples must be properly informed. It means the type of apple must be confirmed to be correct before being sold to customers. Second, manual classification of apples by human is very tedious job. If the number of classified apple is low, then the classification is very easy to do. But if the number of apple is large, then a tool is needed to do classification automatically. Third, manual classification by humans tends to change from time to time. Furthermore, the level of subjectivity in determining the type of apple will have the potential for differences between one person and another. Based on the problems already mentioned, we propose a model using machine learning to classify apples automatically. In our study, two classification algorithms are used, namely k-nearest neighbors and support vector machine. Both of these algorithms are supervised learning, where the model is built by learning training data and their respective classes. Subsequently, the data method levels are tested to determine the classification performance. I will briefly explain how these algorithms work. The first algorithm is the k-nearest neighbors. This algorithm predicts a label based on labels around the observation point. For example, in this image, there are three labels in the diagram, namely blue, red, and purple. The green triangle A is a point which label is not known. By observing the label around point A, we can predict the correct label for A. It is important to note that the number of neighboring points observed will determine the prediction result. In the case that only one nearest neighbor is considered, we can predict that the green triangle place A is blue. If three nearest neighbors are used, then the classification for point A is red. So it is important to determine the optimal value of K to get the best classification result. Another classification algorithm that is quite popular is the support vector machine, or SVM. In the SVM, data is classified based on a hyperplane. Unfortunately, creating a hyperplane in a low-dimensional space is often quite difficult. Therefore, a function that transforms data from a low-dimensional space to a high-dimensional space is required. This transformation function is often known as kernel. Different kernel will produce different accuracy results. In our experiment, these kernels are linear, polynomial, and radial basis function. Before the experiment was conducted, apple images from the market consisting of 4 labels were collected. The 4 labels are Yellow, N5, Fuji, and Manang, with a total of 50 images for each label. Then, the data set is divided into 10 folds with the proportions for the classes set in balance. commonly known as stratified cross-validation. In each sub-experiment, a fold is taken as testing data, and all other folds are used as training data, and it is described in the following table. Experimental results using DKNN is shown here. As can be seen, the best performance results occurred when K equals to 1 with an accuracy rate of 94%. When ESVM is used, the best performance occurs for the linear kernel with an accuracy rate of 94.5%. This result is the best result not only among all kernels tested in this experiment, but also in all experiments with DKNN for all K values. So, the final value of the experiment using the SVM classification algorithm with a linear kernel is the best result of this study. We also note the result from other researchers related to Apple classification. Although with different acquisition and methods, as shown in this table, image classification is not too bad for similar classification fields. Furthermore, these results show that Apple classification with machine learning is promising to be used in practical application. In conclusion, classification using traditional machine learning is feasible to be implemented in practical use. For suggestion in the next iteration, we can add more images and classes to the data set. And also, we can use the deep architect neural network, such as deep learning, to implement the classification of apples. That is all my presentation. Thank you for your attention.